Welcome to demonstration of adaptive software sorter library with CMake with continuous integration and deployment at GitHub, test-driven development using Google Test, coverage report by GCOV, and finally open close principle demonstration. So stay tuned. First we will get the code. The code can be found at GitLab. We will check out the code. Once the code is checked out, it is built on CMake. So we are going to run the CMake, create a build directory, this can also be viewed in Qt Creator. I am running Ubuntu 20.04 long-term support. Go to build directory and type make. This is going to build the software. I am going to open in also in Qt Creator. We'll do it as things move on here. The goal of sorter library is to sort integer numbers up to 10,000 numbers. The objective of this project is to find out how different sorting algorithms can be implemented quickly, how validation of various sorting algorithms can be done quickly, how continuous integration and deployment can be achieved for any C++ library or any other software library, and how coverage can be integrated. Now these are the basic ingredient or basic building block of an adaptive software library. The make is done. Now the library is ready. We can look at the library in we need source, tree is a software to view the directory structure in a visual manner on a command prompt. Take a while. While this is going on, we can look at the GitLab sorter library infrastructure. The pipeline is manual. I have set up because every time it is running, it kind of builds the new pipeline, that is the continuous integration, and it takes minutes out of GitLab. So to stop it right now, I'm doing manual, but you can see the pipelines which have been running, and these are failed, these are passed. Right now it's in a pass state. The tree is done. We can look at the structure. The sorting SO is available as libsorter, which can be integrated with any other sorting application. Now we want to check what is the test case mechanism. The test cases are integrated using Google Test, and you can run sorter test, which is running the sorting test cases for 1 number, 2 number, 10 up to 100 up to 10,000. It also provides how many seconds it kind of ran. 1000, near about 1000 millisecond in total. This is the Google Test. Now we want to look at the coverage. The coverage can be found at the coverage report. Go to any pipeline, which is right now it's built, it's a tip. We can, I have not run this, so going to look at the next one. this was passed in the coverage. We can download. While any job in the pipeline is running, it is showing the console view how it has performed the operations, which is very useful. The artifacts is downloaded. I'm going to extract it right now. The current library supports two kind of sorter. One is bubble sort and one is the quick sort. Let's look at the visual. In the Qt creator, it is more UI, and you can walk through multiple files. The build is then configure project. Currently it is on a master branch. So it's supporting bubble sort and quick sort as of now. We were looking at the artifacts. In the resource, we click on the, and this is the L-curve code coverage report. We can see source and the test. Those are the two folders. In the source, bubble sort is 90 and quick sort is 0 right now because I am doing the testing and I have turned off quick sort as of now. This is the improvement which will be planned. Apart from that, one other thing to observe is Google test is included as a part of the project because the source files needs to be there, which you can find by fetch content mechanism. Once the fetch contents are done for release 1.8, the subdirectory is what is added. The library is built from here and the test case are built using the test application. And the test case are available here. The coverage and continuous integration and deployment can be found at GitLab. You can, this is the client. Integration has achieved on GitLab using the YML file which is supported by GitLab. These are the various stages and these are the commands that we want to run to execute. The GCOV and L-curve mechanism is here to generate the coverage report. Now finally we have a library which is built, which is available for use, which we can see in as an SO. Now this can be integrated with any application. We will look at another project or client to see the demonstration, which is sorter client. This is another repository which is built to validate the sorter library and how it can be used. I have added the header file and library. We can copy here. Let's open the Qt Creator. currently I am trying to search the library in the home folder, and our library is sorter, which we have built it from the previous library, so we are going to use it. Now we can see sorter library client is in action. It kind of uses the factory pattern so that it does not have dependency with sorter actual object. Once it is running, it kind of provides the output. Let's walk through the output. So we can see near about 10,000 integers are populated and output is shown. Randomly, first it creates the random unsorted array, and library is returning with the sorted array with the size and time it took for the application for the integers. Now, to adaptability for this library towards future. What if I have an algorithm, a new sorting algorithm which is independent and which I would like to test? We can use the factory pattern which is available. The factory pattern, we can add a new if condition and a new sorter version can be implemented, which can have an independent algorithm based on the custom criteria. And the second adaptability is, what if I want to add a new, I want to check bubble sort, quick sort or any other sorter functionality. That can be achieved by strategy. We want to have a new sorter algorithm to be checked, then we will provide the, for example, selection sorter. It would be provided here, and we will implement a file which will have its own sorter mechanism. That way, if we want to have in future a new selection sorter, we can go to the sorter alpha, which is right now the primary sorter object, change the sorter strategy to selection sort, and everything will be working as is. That is why this library is closed for modification. There is absolutely no modification into the sorter function. Nothing change in the quick sort, nothing change in the sorter, nothing change in the client which is using it. A new addition of new algorithm as well as new sorter mechanism can be completely independently achieved by two patterns. One is a creational pattern, factory pattern, and one which is a strategy pattern, that is a behavior pattern. That concludes the sorter library algorithm demonstration, and in a conclusion, we looked at a C++ library which can be implemented with CI/CD with GCOV to look at the coverage, and with test driven development. The test driven development is available at sorter test. We can write new test over here and it would support, right? I have currently disabled the 100,000 test case because the bubble sort, when I ran, it was not supporting more than 100,000, whereas if I change it to quick sort, it is working. That is how different algorithms can be tested. Thank you for watching this video, and The library is available as free. It is on GitLab, and I am beyond words thankful to Google, Stack Overflow, mentors, leaders, friends and colleagues who have continuously shared their knowledge across various mediums 24/7, and is available for our learning, understanding as we speak. Without their help, this would not be ever possible. Thank you again, and look forward to the next big version. Thank you. Stay tuned. Take care. Keep coding. Keep learning.